we go. Okay. Hey everybody, welcome to Data Umbrella and Pi Ladies online event. Just to sort of let you know how we're going to, how the event is going to go. I'm going to do an introduction about the Meetup group. Sam Bale is going to give her talk, and we'll have Q&A. We'll also sort of watch the Q&A every 10 minutes or so and answer questions along the way. Just to let you know, this event is being recorded. Okay. About me, I'm a statistician data scientist. I founded Data Umbrella, and I'm also a Pi Ladies organizer, a New York City chapter, and I am on Twitter at Reshama S. The mission of Data Umbrella is to provide a welcoming and educational space for underrepresented persons in the fields of data science. Our website has information. We're on Twitter if you'd like to share about this event. And just so you know that we are a volunteer-run organization, so all the time that is put into organizing these events and running them are on volunteer time. This is co-promoted with Pi Ladies, which is an international group of Python ladies and gender minorities. And they are, you can find for the local chapter, New York City chapter, that's our website and on Twitter. Our code of conduct, to reiterate from emails, we are dedicated to providing harassment-free experience for everyone. Please keep this experience for everyone professional, welcoming, and inclusive. On the Data Umbrella website, there are many resources available, and I took some screenshots. There are resources for open source, for accessibility, and responsibility. So if you want to check them out later on, please do. So to watch for upcoming events, we have them on the Meetup page, but we also have them on Twitter, and we're on social media at LinkedIn, YouTube, and Facebook. So feel free to follow us on whichever platform is your preference. Yeah. And so we're going to get started. Sam is in New York, as am I. Sam, we met through your Pi Ladies organizer as well, the New York chapter. And so it's really exciting to have Sam present on Terminal. I'm going to let her introduce herself.
All right. Great. Thanks for switching over. Hi, everyone. Welcome to this webinar. My name is Sam. At this point, I'm kind of just saying data person. I do data things. I'm based in New York City. I run the partnerships team at a small startup called Superconductive. Superconductive is the team behind Great Expectations. The little gentleman on the side here, that's our logo. Great Expectations is a really cool open source tool for data quality. So here's a very brief plug. If you're interested in data quality, and in using a Python library that's open source and free for data quality, please do hit me up after the talk. We have really cool things going on. So the plan for today, for this talk about an intro to terminal, is to give you some background, talk about terminology, just explain sort of what do we mean by terminal, shell, bash, Z shell, all these things. Then second, go into some basic navigation, file manipulation, some searching. So just kind of like orienting yourself around your file system. Go a little bit into environment variables and what your profile is all about. And then I will do a very brief introduction to shell scripting. In terms of the structure, Reshama already mentioned it. I'll be mostly showing slides. So this evolved from an interactive workshop that pre-COVID we actually used to do hands-on parts. So in this case, I'll be doing most of the talking and demoing some stuff. I'll be stopping after not quite each section, but after each major section for questions. Reshama will field these from the chat, and then we'll also hopefully have some time for FAQ at the end. We're a little it might get a little tight. I might have to skip a couple of things or like rush a little bit, but we'll figure it out. We'll play it by ear. Most importantly, all the slides are going to be online. We'll please post a link to the slides at the end in the chat, so you can also follow along. And there are the little DIY blocks are marked as DIY. There are mini exercises that you can also try out after the workshop. So hopefully this is going to give you sort of an overview and an idea of how things work, and you can ask some questions, and then you can use the slides to like work through stuff by yourself after the workshop. All right, let's get started. So background and terminology. What are all these words? So there's a lot of things that are actually used interchangeably, which is very interesting. And honestly, I had to look up some of this too. So what is a shell? Generally, a shell is a user interface, which interestingly can be either a command line, so kind of what we generally think of as a shell, or it could be graphical. So funny enough, we actually even consider a graphical user interface, a GUI, also a shell. But in general, when we talk about shell, we kind of mean actually the terminal, the sort of black box with a green font that runs a shell. And then we often also use the word bash, which in this case is a type of shell. So it's just one particular program. There are lots of others like Z shell, K shell. I think there's one called fish, but there's a lot of out there. Mac OS, interestingly, switched from bash to Z shell in version 10.15, so that was around last fall. The basics between bash and Z shell are pretty much the same. I think once you get really deep into it, you'll notice the differences. But for me, at my level of like sort of navigating around things, I didn't actually notice a difference between bash and Z shell. So just keep that in mind, that a lot of times, like, we're so used to saying bash, but funny enough, if you use a MacBook, you're actually now not in bash anymore, you're in Z shell. So I hope that's given you just an overview of the terminology. And honestly, like, we use a lot of those things interchangeably because, again, unless you go super deep into it, a lot of times these are pretty much the same. If you use your terminal, that will open a shell, etc., etc. So just to clarify those things. Okay, so now the question, we actually already had a question in the chat, like, why use the terminal and shell at all? Like, there's a lot of people at Apple and Microsoft and Linux that at Linux distros that spend a lot of time on usability of their graphical user interface. Why should we even go back to the terminal? So one reason is it's often a lot faster or more flexible than doing things sort of by clicking. One of my lecturers had a class called "The Keyboard is Mightier Than the Mouse." So a lot of times it's really easy to just like write a one-liner and do, for example, bulk operations on files, to search for files and text, some things that don't work quite as well in your operating system, your GUI. So that's sort of my preference, is a lot of times there's something that's just a little easier to do. Second, sometimes you have to. Even just like navigating around the file system to like run, start up a server or run some programs, run some Python code, whatever. Like, a lot of times you just do that from your shell. So you kind of have to. Another good example is if you connect to a server, if you run any kind of jobs or anything remotely, a lot of times you SSH into that server or have some other way of connecting to it, and you only have your terminal, you don't have a GUI that you can click around. Another thing is things like setting aliases or environment variables. So if you've ever used Postgres, for example, there's an environment variable called PG password that you set to set a password. There's things like your Python path if you're using Python. I'm kind of just assuming that a lot of people here are data sort of you work with data and are maybe close to Python and have some familiarity with that. So I'm kind of making a lot of Python references, I think. So a lot of times you just kind of have to, the only way to do things is via your terminal. So it's very, very helpful to just have some familiarity with it and be able to kind of navigate and find your way around that. I hope that's given you an explanation as to like the motivation of this. So let's just dive right in, navigating the file system. So some basics to navigate the file system. We have, and the way I'm going to do this is I'm going to do the boring stuff and actually just read these things out, and then I'm just going to pull up my terminal and show you. So we have several commands to navigate the file system once we're in our shell. We have pwd, which is the path of our current working directory. And usually your terminal will open a shell in your home directory. So we'll see that in a second. You can do an ls, which just lists everything that's in your directory. And then pretty much every shell command has a flag. So the flag is usually the dash something. In this case, ls-l adds a long format flag, and ls-la adds you can concatenate the two flags, so say long format plus show all. So I can show that right now. So I'm currently in my terminal workshop directory, so the workshop where I have all the content for this. I hope this is big enough for everyone. So let's just do this. I do pwd, which says I'm in user Sam code terminal workshop. So this is the current working directory that I'm in. I can do an ls. ls just like shows all the files that are in this directory right now. I can do ls-l, so I'm adding this flag, which shows me all the files plus some additional information about the files, such as the permissions, the owner, the group that's on the, I'm actually not sure if this is the last edit date or the creation date. This must be the last modification date because I've updated my slides recently. So this is last modification date. So this is the long format flag. And then I can also do ls-la, which lists all. So this also gives me some of the hidden files. So the all flag gives me hidden files. As you can see, I have a .git directory here and then .idea for my PyCharm IDE that's created. So just to give you kind of an idea of like, this is usually the first thing, and you use that a lot, like pwd to kind of see where you are. You use ls to see what's in the directory. So now how do I know what flags are possible here, right? How do I know I can use -l, la something else? There is a command called man, man, which stands for manual, and that's built in. It's a Unix command, and I can just say man, and then something like an ls, for example. So the command that I want to have the manual for. Do that, and I get a really cool commands manual that gives me all the information. So this is kind of the documentation about the command that I just typed about ls, and it shows me, so I can use the spacebar here to go through this, and it shows me all the flags that I've just used. So this -a that I've just used, include directory entries whose names begins with a dot, or the -l that I've just used, list in long format, etc., etc. So just to give you an idea, man, gives you the manual for pretty much all shell commands that are built in. It's super helpful. There's also a lot of Easter eggs in there. These been around for a few decades, so there's occasionally some fun stuff to find in there. The way you get out of man, you can see I have this blinking cursor right at the bottom. Actually, what I'm going to do is I'm going to make this just tiny bit, move this up a little bit. I have this blinking cursor at the bottom, and once I see this blinking cursor, all I do is press Q. Obviously, you couldn't see what I just typed, but I just hit the letter Q to get out of man. So that's just an overview of like some of the very basics. Great, cool. All right, so let's actually move to the next slide. Some helpful shortcuts. So one of the things that actually I teach almost everyone I work with who I see not using things. You don't always have to type everything in your terminal by hand. So there's some really cool shortcuts or some really cool helpers to navigate just the terminal itself. One example is I can type clear, and I'm actually going to show this now. So you can see all my stuff is kind of pushed to the bottom. So I write clear, and it clears it up. So it just like moves everything everything up. I can use my up arrow. So instead of typing clear again, all I can do is hit my up arrow. And you can see I didn't type anything, right? It just gives me the previous command. So I can hit up, 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 up each time, and it shows me all the previous commands. Batch will also tab complete things, which is great. So if I want to say, for example, if I want to write a command, Anything that my shell knows about, it will try to autocomplete. So in this case, I only typed CL and then hit tab, and it actually suggested a bunch of stuff to me. So I can do this, and it autocompletes. So it just works like a tab complete or autocomplete. Let's say in your IDE, for example, if you're writing code, that also works with directories, which is really helpful. So there's a lot of really cool stuff. Oh yeah, and so Smita just said that I can also hit Control plus L to clear my screen. So hang on. So yes, I can also, there's also a shortcut. So speaking of shortcuts, there's a bunch of shortcuts with Control plus something. So the most important ones to use are, I can do, so let's assume I've just typed something and I want to go back to the beginning of the line. I can do Control plus A. And again, you don't see what I'm typing, but just trust me, Control and the letter A takes me to the beginning of the line. And Control plus E takes me to the end of the line. So it just moves my cursor to the end of the line. One other helpful thing is if I'm typing multiple words and then I realize, oh, I'd actually want to change this, Control and W removes the word that's right in front of my cursor. So, which also, and spaces are also considered words. So this one will take me to this, will take me to the beginning of the next word, including the space. So I can basically just like remove all the words that I've just typed or the commands that I've just typed one by one. And then also if I've typed a command, but I don't actually want to run it, Control C will basically just cancel this and move me to the next line. So there's a bunch of stuff. And again, this is something that, you know, this is a good thing to do on cheat sheets, to just look up. You don't have to memorize all this. But at some point, it will become second nature. Oh, the one really interesting thing is Control R that I want to show. So I've shown you Control, just the up arrow, right, which loops through all the commands. Let's assume I want to find the ls command that I just wrote because it's like super complex. One thing I can do is hit Control R. It takes me to the back search. And then I can type ls, for example, and you can see it searches in my history for this terminal. It searches all the times that I've written anything involving ls, and then each time I hit Control R again, it shows me. Yeah, you can see I've done a lot of LSs. So each time it shows me like the last time I've used ls. So this is the way I always use this is for my MARP, which is the code that generates these slides that I've just shown. I can never remember the syntax, so I just Control R, and then I find the MARP command, and I don't have to memorize it. So this is super helpful. There's a question in the chat, actually, what's the difference between Control and Command? I think it's actually exactly the same. So on my MacBook, it's Control R, and I think it's the same in the terminal on Windows if you use Git Bash. All right. Cool. So navigating a file system. So now that I know where I am, one thing I want to do, I don't want to just be stuck in my file system forever, but I actually want to change where I am so I can, for example, execute code in a different directory. So there's a bunch of things I can do. Let's assume I open a new directory. And as I've told you, oh, this is fun, sorry. Okay, so I actually set this is really funny. I actually set my terminal to open to open a new tab in the same directory where I had my previous tab. Generally, all the terminals by default are set to open in your home directory. I set mine to actually open in the same directory, but let's assume I'm pwd. I'm in this directory, and I actually want to go one level up, for example, to see all my directories that I have under code. So I can do cd, and then I can either type in the name of the directory that I want to go to. So users sam code. And as you can see, I am now in user sam code. Or alternatively, one of the things I can do is use one of the nice aliases that we have. In this case, it's ... to go one level up. So now I am in user Sam, right? So the dot dot helps me navigate around. There's another CD change directory shortcut. That's the tilde. Tilde takes me to my home directory. So as you can see, oh, this is the same user Sam. Let's say I go back into code. So now I'm in user Sam code, and I go to CD tilde. I'm back up in my home directory. So the key shortcuts or aliases that you can remember here are, let's look back, the tilde, alias for your home directory, the dot, which just means the current directory, and the dot dot, which means the parent directory. And one of the things that you can also do is just concatenate these. So I can say, for example, I want to, let's go back to code, terminal workshop. I can say, and just use the dot dot as a file path. So this takes me not just one, but 2 levels up. So in the second, like the grandparent. Right? And then I'm back in user Sam. So I skipped the code directory here. So just one thing to keep in mind is this: with CD, you kind of navigate around, and you have a bunch of aliases to take you to specific directories. All right. Cool. Basic file operations. So I'm going to move a little bit faster just because we're really tight on time. Okay. There's a bunch of basic file operations that you might want to use. The keywords here are Meetup, touch, and open. So I can show this real quick as an example. So let's just go back to my code terminal workshop directory. I'll do an ls to see what's in there. I'll also clear real quick. So I can do a make dir, call it Mightier. And as you can see here, I just created a directory called Mightier. Okay, so so I can go into Mightier. And then I can, if I want to create an empty file, honestly, touch, I mostly just use it to test whether I have permissions to create anything in there. Usually, obviously, if I'm creating like any kind of file, I'm using a text editor for that. So touch new file.text. And you can see I created a new file. And then if I want to, I can open new file.text. And this will open it in my whatever is set up as a default editor. In this case, it's really just my Mac OS default text editor that opens new file.text. And I have a new file that I've just created here. So just one example of how you can like quickly, if you want to, often like for configurations or if you want to store anything there, this is kind of a quick way to do this, and you don't have to click around through your text editor, navigate in your Finder and stuff. I really like doing this. All right, file operations number 2. This is where it gets really interesting because you can do copy. You can move and rename files, and you can remove files from your command line. And this is where I think things start getting more powerful than if you do them in your Finder, because you can sort of bulk modify stuff. So let's assume I have a file hello.txt. Okay, do an ls. I have hello.txt, new file.txt. I can copy hello.txt to, let's say, hello2.txt. Just making a copy, and you can see I now have hello.txt and hello2.txt, and the content of those would be identical. So now I can rename on the command line hello2 to, let's say, hello3 for whatever reason. I rename that. And then if I do ls again, I have hello and hello3 because hello2 was renamed to hello3. This is pretty straightforward. So this is this, and then also if I want to, I can remove, let's say, cleanup new file.txt. So I can also delete my new file.txt by just typing rm for remove. So this is where this gets powerful, is by using wildcards. So the wildcard operator is the asterisk, like the little star. And this is where I can do bulk operations. For example, if I wanted to remove every single file called hello.something in this directory, I could just say remove hello. Okay, I'm doing this. This is, let's consider it irreversible, so please do use this with caution. But I can basically just say remove hello.text, hello, anything that starts with hello. And if I do an ls again, I have nothing in there because I just removed hello.text and hello3.text. So this wildcard operator is really, if there is one thing you take away from this that you don't know yet, I think this is super, super helpful because that allows you to do bulk operations. You can also use it in a way such as hello.star, for example, or .csv to remove all your CSV files, or you can do it to, for example, do an ls to just list everything, to show everything that starts with hello and is a CSV file, etc., etc. So you can do lots of stuff with that. All right. Looking at file content. So, and again, like I'm picking up speed a little bit. Just to get through the key stuff here. Again, this is all going to be on the slides. So I have a file, a sample CSV file from the New York Open Data website as an example. And there's a bunch of stuff you can do to look at CSV files. So again, just kind of going back to what I said about this is a little bit aimed at data folks. And this is this kind of stuff that you do a lot, or that I do a lot. So let's go cd up into my directory, do an ls to see I have my permits.csv. So let's assume I've downloaded permits.csv and I want to know what's going on with this file. And I don't necessarily want to open it in like Excel or read it into a pandas data frame or all that. I just want to get an idea of what's in that file. So I have different options. One, which is a little bit of the danger zone, but I can use a command called cat. Cat really just prints the entire file to the screen. The reason why I'm saying this is a danger zone is because that might be a very large file and it might just push a lot of content to your screen. In this case, I know it's large, but it's not crazy large. So let's just run it. So I'm running cat, and it basically just printed everything in that file to the screen. And I can, if I want, I'm actually able to just scroll through this. So cat is kind of cool for smaller files in particular to just print the whole thing to the screen immediately and you don't have to open it separately. Another really cool command is that I actually find more useful than cat is head. And you also have a matching tail. So head gives you the first n rows of your file that you're looking at. So in this case, if I have head permits.csv, and I think it defaults to 5 or 10, 10, sorry. It defaults to the first 10 rows. So in this case, especially for like things like CSV files, this is always really nice for me to see the header row and to get a little bit of the data. So this is literally the head if you're using pandas. This is the head for pandas. And then in addition to head, we also have a tail, which gives me the bottom few rows. Oh, nice. And I do actually have to, okay. Head, and again, just like in pandas, if I want to only see the top something rows of this file, I can also do -n, which specifies the n, like the n number of rows that I want to see. And I can say, I only want the top 2 rows. So now you can see, let me repeat this and just do this. Now I can it only prints the top 2 rows. Just keep in mind, like this is a CSV file. Obviously, head does not know that this is a CSV file, so it doesn't give you the top 2 data rows, but it gives you the top 2 text rows or text lines in whatever file it is that you're looking at. And you can do the exact same thing with tail. Boom, so that gives me the bottom 2 lines. Pretty straightforward. This is super helpful, I think, if you download a file, you get a file from somewhere, and you just want to get a quick look without opening anywhere else, like head and tail, cat head and tail is super helpful. I'll actually pause for, oh, got it, yeah. So head gives you the top rows, and tail gives you the bottom rows. So tail starts counting from the bottom, head starts counting from the top. I'll actually pause real quick to see if there's any other questions. Yeah, so a lot of the things, this is an incremental workshop, so I'm actually going to talk about less too. So thanks for mentioning that. It's all coming. Any other questions? All right, great. Let's keep going. So speaking of which, so a nicer way to navigate around files is to use a command called less. Less is basically an interactive text reader that allows you to do a little bit more navigation. So one thing that you can do is just say less and then premise.csv. The reason why it's called less is because there's also a program called more. Less is basically more. Oh my God, less is more, but with more functionality. Unix things are funny and weird and quirky, and it's been going on for a long time. And this is like, read up on it. It's pretty funny. So if you say less permits.csv, less is the interactive text reader. So again, it shows you, it starts at the top of the file. You can navigate around really just using the arrow keys up and down to go through the rows. You can use your space bar to page between whole pages, right? Or there's also some really cool built-in functionality for searching in less. If you use a /, so again, you see the blinking cursor after the colon at the bottom. If you use a /, that gets you into search mode. So now I can, for example, say I want to find everything that says film. So I just type in film, and it shows me all the search results for film. I can navigate through those search results using P and N. P stands for previous result, N stands for next result. So, well, this is the top of the file, so I keep going down, and you can see it just bumps the line where it finds that search result to the top of the screen. So it just moves it up and highlights it. Keep in mind the search is case sensitive. In order to make it case insensitive, you type -I. Wait. Okay, and then you ignore your case and searches. So -I gives you case insensitive search. So now I can also search for film. Oops, wait. Oh, this is not found. Sorry, I'm like getting mixed up. Okay, ignore cases. There we go. Okay, so, and then I can navigate through that, even though I've searched for lowercase film. And again, just like with MAN, with man, most of the time for a lot of Unix programs, the way to get out of whatever it is you're stuck in, just hit Q and it'll get you back out. All right, so that was less. Next up, I've actually already explained finding text in files, so less is a really good way to do this. There's a bunch of other ways. So this is option 1, is to use less. Option 2 is to use something called grep. Grep, actually, I don't know, you might have heard someone even saying like, oh, I'll just grep for this. Like grep kind of, and by that we mean GREP, not GRAB, not grab, but grep. So grep is also a Unix tool that comes built in your shell that allows you to search in files from your command line. So I can show this real quick. So you just type grep, then you type your search word. Yes, sorry, I get the syntax mixed up sometimes. So you search your search word. So in this case, I'm grepping for the word film in my permits.csv file. And it doesn't give me a result. Why do I not get a result? Because it's case sensitive. So if I grep for film, it now prints every single line where it finds the word film. The other way to do this is to say grep-I and then search for whatever case. I can even do this. So -I makes it case sensitive. And again, this is one thing that like occurs in so many contexts in your shell. So many programs, like the -I usually makes things case insensitive. Okay, and it just found, and then grep just prints all the different, all the lines where it finds that search result. So again, if you're working with data, like this is occasionally pretty helpful to just search really quickly for a specific word or specific lines that contain the thing that you're looking for. You just grep for it. All right. The way I use this a lot, that I use grep a lot, is if I don't want to just print all the lines where I find something, but I want to actually see the recurrence. Swati, I see you're asking to go back to the slide for less. I think this is it. I would like to keep moving though, but the slides will be online and you can totally do like look things up afterwards, just in the interest of time. Okay, so sorry, jumping back, the pipe operator. So the pipe operator chains any two commands and pipes the output of command A, of the first command, into command B. So I'm going to show an example. Again, I'm going to clear my screen. So one other tool that's super helpful is word count, WC. Word count -L counts the number of lines in a specific file. So in this case, if I want to count the lines in my permit.csv, I do WC-L permits.csv, and it tells me I have 42,000 rows. Again, keep in mind, word count, again, doesn't know that it's a CSV file and that it has a header row, so this always includes the header row if you're looking at data, if at CSV files specifically. It just says this is a number of lines that I see. So one way to use this is to pipe the output of your grep to your word count. Okay, so I'm going to show this by grepping, right? Case insensitive grep. So I want to see, get all the lines that contain the word film. So I want to see how often do I see the word film, and then pipe this. Whoop, I'm going to make a space. Pipe this to word count. And keep in mind, I don't need that argument. I don't need the permits.csv argument here, because word count knows through the pipes that it should be counting this input. It should be taking this as the input rather than having an argument as the input. All right. So what do you think happens? I'll give everyone like a second to think. What do you think is the output of this? So the output of grep-I, film permits, etc., pipe word count-L will be a number. Oh, that's a fantastic question. Once I'll finish this. So it'll be the number of times that the word, the number of lines where the word film occurs. Okay, which is probably, I don't know, somewhat less than the 42,000 that we have in the file. All right, we have exactly 7,410 lines where the word film occurs, which means there could be multiple occurrences in one line. This is really just to give you an idea of this. But again, like if you know your data pretty well and you know your CSV structure pretty well, this can often be super helpful. So yeah, we have 7,410 lines that contain the word film. Might be multiple mentions of the word film. One thing that you could get really sneaky is to do this and basically be prescriptive about your CSV structure. And in this case, we know it only occurs once per line. All right, great. So that was, I will actually skip this part just in the interest of time. Actually, no, this is, we'll have time for that. Cool. Okay, so this is searching stuff in a file that you already know is there. So I know I have my permits.csv, and I just want to do some like data manipulation, data searching and stuff. Cool. One thing that you also might want to do is finding files. And I think honestly, in this case, I find the terminals so much easier to use than the Mac OS search. I don't know why, but the Mac OS search to search for specific files with a specific file types just always turns into a huge pain. So one of the things you can do is use a command called find. Then you always have to specify the directory. And remember, in this case, in this example, the directory could just be dot, right? And then you have to specify the flag, which could be, in this example, there's tons and tons and tons of flags to find. This is kind of the most common one. Either dash name or dash iname. Again, dash I is case insensitive. So dash name or dash iname. And then you can basically just search for anything in your quotes that is in the file name somehow. So I'm going to show this real quick. So in this case, where am I? Okay, so I'm going to find in my directory, let's say I just want to find any CSV file, right? So I want to find anything. Again, you can use asterisk for a wildcard, and want to find anything that says, oh, because I did not use my dash name flag. So I'll just do that again. So again, find in this directory and everything below. Find is recursive by default. Find anything that in the file name has something matching .csv, something that ends in .csv. In this case, not that exciting. It's only my permits.csv. To show you that it is really recursive, I'm actually going one level up and just repeating that. Let's say with anything that starts with NPI. I have a lot of NPI files. It's a healthcare provider index files, and I use this a lot for testing. So I know all my code, all my repos have a bunch of copies of this. So I can do find dot dash name. Actually, let's do a dash iname to see if there's anything that's also an uppercase NPI. So anything that starts with NPI, blah, 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 and ends in CSV. And it shows me a bunch of NPI CSV files. The way I use this a lot of times, which is really cool, is basically say, how often do I have this file in my directory? So thinking back to the pipe operator and word count is I can basically pipe the output of find to my word count. So this, instead of me counting each line 1, 2, 3, 4, 5, I can just say this, boom, and it tells me it's there 9 times. So this is a really cool, and this is something that I don't even know how I would do this using my Finder or Explorer on Windows or Mac. This is something that I think is just a really nice, quick one-liner in your shell. Anything else about find? Again, keep in mind it's recursive by default, which is super, super helpful. A lot of times for a lot of commands, you have to specify recursiveness. Oh, and the other thing, you can also specify a specific directory to search in. So it's not just dot as in like this directory and anything below, but you can say, okay, find everything in, let's say, code. Let's find everything in my code directory, which in this case is the same, that says npi.csv. So there's ways to basically point it at a directory to look at. Great. Any questions so far about find? And again, like find has a lot of flags, a lot of functionality. This is just sort of the most frequently used one for me. Right. This one I'm going to go through real quick. Environment variables and profile files. So environment variables are system-wide global variables that your shell knows about. You can literally just type in env, and it will show you all the environment variables. I don't think I have any passwords stored here. So these are all the, oh, there is a password in my Postgres connection screen, so I won't show you that. It's all dummy data. It's all our test databases, so I don't have any concerns. So env shows you all the environment variables that your shell currently knows about. And you can echo a specific variable by referring to it using the $sign. So this is across shells. Variables are referenced by the $signs. So I can say echo user. So user, and everything is case sensitive in your shell. So my user is set to Sam. Or I can say, this is the thing that you probably see a lot, your Python path. Oh, that's interesting. My Python path is empty. Let's see about my path. Okay, so my path, for example, has conda things mostly, and then executables and binaries. So now we learned two things. One is echo. Echo hello. Echo just prints anything you throw at it. And the other thing is you reference environment variables using your $sign. So now the question is obviously, cool, these are the environments variables that are built in, right, that are set somewhere. How can I set my own environment variables if I want to use them in any like script, for example, or if my application wants it? Again, like my Python path for some reason is empty. A lot of times it says add it to your Python path or set your path. So you set environment variables using a command called export. I can show that real quick. So the syntax is export, and then you assign the name of the variable, and then you say equals the value. So this is pretty straightforward. Export myvar equals 42, or some text in quotes. Shells are very, very sensitive to spaces, quoting, etc., etc. So make sure like the syntax is correct. One thing I can do is echo export myvar, and when I'm setting it, I don't use the $sign. Is hello. This is very boring. And then I can say echo myvar. So now I use the $sign to reference it, and it says hello, because that's the value of my variable. I can also overwrite this. So if now I want my var to be, say, 43, and I echo it, now it's 43. So this is a really nice way to set your environment variables in your shell, in your terminal. It's basically a global variable that your particular shell knows about. The only problem here is if I open a new tab, and I'm using a different terminal from usual, so I'm not sure if this actually sources it, but let's see what happens. If I type echo myvar in new tab, it's empty, because the wherever I set my environment variables, only that shell actually knows about that environment variable that I just set. That kind of makes sense, I guess, because there is a scope to that variable. The way to make that permanent, if I want my var to be available in all my shells, like in all my terminals that I open by default, is to set what's called a profile file. So you might have heard of something called a bash profile, or shell profile, or bash RC, or other things. And I'm really just going through this real quick. There is a profile file that every terminal reads at startup, and it does what's called sourcing your environment variables. So if you're using bash, for example, if you're on git bash, it's usually called bash profile or .profile bash RC. There are differences between them. Please do read up, but it gets pretty nitpicky. For C shell, so the whatever the default is on Mac OS right now, it's a file in your home directory called Z shell RC, and I can cat this as we've done before, because I know mine is pretty small. And this is basically everything that's in my Z shell RC. So it does a bunch of exports. It sets, like, I use Apache Airflow. It sets my Airflow home to this. It conda adds some stuff if you add it. I've got a bunch of aliases for Git. And every time you open your terminal, your terminal will look at this file, at your profile file, and create all these variables so you have them available. So I'm not going to show the example, but you can totally go through that in your on your own when you have the slides. Okay, last thing, shell scripting 101. Instead of typing all these commands to the command line every single time, that gets pretty annoying. You can basically just dump all your commands into a script. So I can show you that. Clear, and I go into Terminal Workshop. Okay, so I have this file samscript.sh that I prepared. And again, I can use cat or less, for example, to show what's in the content of this file. And in this case, it's just one line that echoes something really boring. The way I can run the script, there's multiple different ways. But I can basically say, for example, samscript.sh. This is one way to execute my script. So what I would expect to happen is for this is for the echo to just print to the screen. So basically all I want to see is, hello, this is the script saying hi, if I execute the script. Well, that doesn't work. Permission denied. Why is the permission denied? If I go back to the line that I'm highlighting here, this block at the very beginning actually shows you the file permissions. And in this case, what I see is I have read, write permissions. So I have this on the slides for more detail, but basically you have read, write, execute, read, write, execute, read, write, execute for user, group, and other. And in this case, I can only read and write, but I can't execute my script. So what I have to do is change my permissions. The way you change your permissions is yet another command called change mod, change the mode of my file. And I'm just going to make some magic happen right now, real quick. Let's see, plus X. So I'm setting the user get execution rights on samscript.sh. I'm changing the permissions of what I can do with the script. So if I go back and do an ls.la, let's do it just on the samscript.sh, you can see that read, write, execute. So now I have set plus X. And that means I can execute and run my script. Boom. Really, really, really basic. This is just the very beginnings of shell scripting. You can do for loops, you can do whiles, you can do counts, you have data structures in there. So shell scripting is a whole new topic on its own. This is just basically me showing you that you can take any shell command and dump it into a file, change the permissions, make sure the permissions are right, and then you can just run it. All right, I'm going to wrap up. So we have a couple of minutes left at the end for congratulations. This was it. I'm going to wrap up and do a quick summary at the end. And then we have a couple of minutes for questions. So what we've covered, directory navigation, file manipulation. So remember PWD, LS, CD, copy, move, remove, and all that. We've covered searching for text and finding files. So we copied less and grab and find. We've covered environment variables and your shell profile, and I've showed you a tiny, tiny little shell script. This section is actually super important because this really, you had the tiniest overview of anything I could squeeze into this 1 hour. Other important things to look up. Sudo command, super important. Sudo command means you basically overriding default permissions, and you're doing something as a super user. So you will run into this sooner or later, so look it up, what sudo does. One thing that's super helpful, this is just a nice to have, is setting aliases for shell commands. You might have seen that I have a bunch of aliases for my Git commands just because I don't want to type that much. Text manipulation, so using Vim as a text editor, even if it's just the most basic commands for Vim, super helpful. For all you data folks out there, CSV Kit is a super awesome library that allows you to do some really cool CSV manipulation in your command line. Strongly recommend looking it up. So remember when I said like your find or your grep or all that doesn't know that it's a CSV file, it has a header row, etc., etc. CSV Kit basically knows that you're dealing with a CSV file or we're dealing with data, and it knows about columns, it knows about rows, so really cool. One other interesting thing to look up is ways to kill and exit, kill processes and exit things. For example, if you're starting up a Jupyter notebook, you can control C it. Sometimes processes hang, you have to do other things. So do look that up. How do you exit, basically kill processes, and what's the difference between control Z, control C, control D, and all that. And then there's other fun stuff like cal, for example, date. You can check disk space, looking using things like du, dh. There's some fun utilities called cowsay. Cowsay just overwrites echo and prints a cow. So there's a bunch of other fun stuff for that's built into your shell. But this is really I only just scratched the surface. So, and again, the slides are going to be online. So I know this was like a whirlwind tour pretty fast of all the terminal stuff. I hope this was helpful. I hope this has given you some idea and some idea of like what the key things are. Does anyone have questions? We have 2 minutes left for questions. All right. If there aren't any questions, I can maybe see if Cowsay works on my laptop. Oh no! Can I just brew install it? Any other questions? Ooh, okay, this might work. Oh, Angel, that's a great question. So Angel is asking, how important is Bash or shell scripting for job searches? You mean for the job search itself, or for actually for getting hired? I assume you mean like for employers. So this is really interesting because I actually think, based on my experience interviewing candidates and looking at resumes and stuff, no one ever tests for that in a job search. Like no interviewer will ever like test your scripting skills. I think it's something that comes out very quickly in your productivity. So I do think being really good at scripting things and navigating around your shell will increase your productivity pretty quickly, and will just show that you kind of know what you're doing, and will, stop you from like manually having to do a lot of clicking and stuff. I do think in terms of like actually finding a job, it's usually not part of the interview process, so you might not need that. So Kimberly, going top down. Candida asks, CSV kit, like you ran number of times specific words appear in a file. I don't actually know about CSV kit specifically. I would recommend look it up. It's got a bunch of really cool stuff in there. So that's all I can say is I don't know exactly, but try it out. And then Kimberly asked whether there's a good resource for translating shell commands into Bash Windows friendly shells. So 2 things. One option on Windows is something called Git Bash, which Bash usually comes with, if you install Git for Windows, it will also install Git Bash, which is a wrapper around your Windows command line that is Bash-like. It's not that great, honestly, but it does the job for some basic stuff. About translating between Bash or just the Unix shells and Windows shells, I don't actually know. Fantastic question. I will find something. I'm actually very, very curious. I'll find something and put it into the repository, put it in the slides. That's a great question. Thanks, Kimberly. I know we're over time. Sorry, everyone. Any other questions? Scripts I would run often to increase efficiency. Great question. So I think I use find on the command line a lot. So it's not necessarily scripts to run, but it's just commands to run. There's other things you could do to have like a little script that, for example, copies or bulk renames files. So if you do a lot of file operations, I think that's one of the examples, like just moving files from one directory into another, for example. Those kinds of things that you usually do by clicking for bulk operations. I think that's the biggest efficiency win. Yeah. Any other questions? All right. I think I'll, and feel free, just I'm going back to my slides. Feel free to connect with me on Twitter if you have it as SPBale, or connect with me on LinkedIn. If you have any additional questions, more than happy to answer them. Let me know. I'll hand this back to Reshama to wrap up. Thanks, everyone.
Hello. Just want to make sure you can hear me?
I can hear and see you.
Yes. Yeah. Okay. Great. Thank you so much, Sam, for your presentation. And there will be a recording which I will post on the Data Umbrella website. And thank you so much for joining us. And thank you, Sam, for the presentation. A lot of people really enjoyed it.
Thank you so much. It was great. Thanks for all the questions. They were really good.